This video on angles is probably the most important one of the circles unit, so you're going to want to make sure that you pay extra close attention, and if there are ideas or concepts that you need to refresh in your memory, it might be a good idea to revisit the video. Alright, first things first, we're going to start by talking about what a chord is. A chord, very simply put, is a segment whose endpoints are on the circle. So if this is my circle, anybody who has endpoints on the circle is a chord. Alright, anytime we have two angles, or angles that are formed by chords, it's going to be inside the circle, but unlike the central angle, not necessarily at the center of our circle. Now the measure of this angle that's formed when two chords intersect is equal to half of the sum of the measures of the intercepted arcs that are associated both with the angle and with its vertical angle counterpart. So that's a little bit confusing. Let's see if we can take that apart and make it make some sense. What this is saying is that if we want to find the measure of angle 1, notice that its vertex is inside the circle, but unlike the central angle, its vertex is not at the center. His measure is going to be formed by taking the sum of his intercepted arc, and if we look at the picture, his intercepted arc goes from A to B, and the intercepted arc of his vertical angle. So if we look across, there's his vertical angle, and the intercepted arc of the vertical angle is going to be the measure or the arc from C to D. So in other words, the measure of angle 1 is going to be equal to half of the sum of the measure of arc AB plus the measure of arc CD. And the other pair of vertical angles in this picture, this angle over here and angle 2, they also have a pair of intercepted arcs. That arc goes with that angle. The blue arc over here goes along with angle 2. So the measure of angle 2, again, his vertex is inside the circle but not at the center. So his degree measure is going to be half of the arc that belongs with him, so arc AD, and the arc that belongs with his vertical angle, which is arc BC. Alright, that's the first important rule that you need to remember for today. Anybody whose vertex is inside the circle has a degree measure that's equal to half the sum of his arc and his vertical angle's arc. Alright, the next segment that we're going to talk about is the tangent. A tangent is either a line or part of a line that intersects a circle at exactly one point. So if this is my circle, anybody that's tangent to the circle would bump into that circle at exactly one point. The next type of angle that we need to take a look at is the angle that's formed by a chord and a tangent. This says it has its vertex on the circle. So if we look at the picture, segment or line TS would be tangent because it touches the circle in exactly one point. QR would be a chord because his endpoints are on the circle. The degree measure of that angle formed when these two guys intersect is found by taking half the measures of the intercepted arc. Now take a look at this. This is kind of neat and it ties back to what we did a couple days ago. Notice that his vertex here, angle 1, has a vertex that's on the circle. And anytime we have a vertex that's on the circle, the degree measure of the angle is always going to be equal to half of the intercepted arc. So the measure of angle 1, his degree measure is going to be equal to half of the arc that he intercepts. Well, the arc that he intercepts going around the circle is from point R to point Q. So half the measure of arc RQ. And likewise, this guy over here on the other side, angle 2, his degree measure is also going to be equal to half of his intercepted arc. Well, his intercepted arc is this arc that starts here at point R, where we're tangent to the circle, and goes all the way through M and over to Q. So the measure of angle 2 is half, And because that's a major arc, it travels more than halfway around the circle, I need to name it using 3 points, R, M, Q. So that's the second big idea for today. All right, another new vocabulary word, secant. A secant is a line or part of the line that intersects the circle in exactly 2 points. So it's almost like a chord, except that it keeps on going. It doesn't end. All right, so let's take a look and see what happened when secants intersect. So it says all angles formed when secants and tangents intersect will have a vertex that is outside of the circle. So if I look at this picture down here, this secant from E to G and secant IG intersect at point G. They form an angle whose vertex is outside of the circle. We find the degree measure of this angle by taking half of the difference of the arcs that are intercepted. So this one is kind of unique in the fact that it intercepts 2 arcs. If I take a look at these 2 secants, they have an arc right here really close to point G, the vertex, and then they also have an arc further out here on the other side of the circle. So the difference is going to be the difference between the 2 degree measures of those arcs. So the measure of angle G is going to be half of the difference between the larger arc first, measure of arc from E to I, subtract the smaller arc, the measure of the arc from F to H. So that's kind of a lot of information. And I'm going to summarize it in a table up at the top of the next page just to try to give you something to hold on to and help you remember. So in reviewing what we did a couple days ago, we said anytime we have an angle whose vertex is at the center of the circle, we said the degree measure of that angle was equal to the measure of the arc. Inside the circle but not at the center, that one was a new one from today. We said that the degree measure of the angle was equal to half the sum of the degree measures of the intercepted arcs. Outside the circle is a new one from today. We said that the measure of the angle is equal to half of the difference between the intercepted arcs. And then anybody whose vertex is on the circle, the measure of the angle is going to be equal to half that of the arc he intercepts. Now that said, this last rule does have one exception. The exception to that is the angle that is formed when a secant intersects a chord and the vertex just happens to be on the circle. If this happens, we're going to find the degree measure of the angle by using other angle relationships. And when I say other angle relationships, maybe there are 2 angles that form a linear pair, and so you'll know that they have to have a sum of 180. Maybe there'll be something that's part of an angle in a triangle, in which case you know that they need to sum up to 180. But use some other angle relationship to find the degree measure of that angle formed by the secant in the chord. All right, so let's get into some problems because we know that we've got a lot of new rules now to practice and to get used to and familiar with and comfortable with. All right, so in the first one we've got tangent AC. They want us to find x. The very first thing that I'm always going to do is I'm going to go find the vertex of the angle, because finding the vertex of the angle dictates to me exactly which one of the rules that I'm going to follow up in that chart above. So this guy has his vertex that's on the circle, and because his vertex is on the circle, I know that the degree measure of the angle is going to be equal to half that of the arc. Now I need to go find the arc. Well, this angle extends through this point up here, and it starts here. So the arc is going to be that green arc right there. I don't know his measure, but I do know that all the way around the entire circle has to be 360 degrees. So if this part over here makes up 240, I know that the green arc must make up 120. So now the degree measure of angle x has to be half of the arc that he intercepts, or half of the 120, or in other words, 60 degrees. All right, number 2 has to do with another angle. The very first thing that I'm going to do is I'm going to look for the location of that vertex. That vertex is outside of the circle. So if I look up in my table at the rule, it says the degree measure of the angle is equal to half of the difference between the the measures of the two intercepted arcs. So if I look here, I've got 2 arcs that are cut off by this angle. I've got a blue arc there that's in between the 2 sides of the angle, and a blue arc over here that's in between the 2 sides of the angle. The smaller arc I know, the larger one is going to be a little bit trickier. But if I think about this circle, from here, halfway around the circle, over to here is 180 degrees. The remaining arc is also going to have to be 180. So if I subtract 20 and 100 from the 180, it tells me that that blue arc over here has to be 60 degrees. So the measure of angle X is going to be equal to half of the difference between the larger of the 2 blue arcs, 60, and the smaller of the 2 blue arcs, 20. And notice that I'm showing up here exactly which numbers I'm plugging in, exactly how I'm finding my work or my solutions. You need to make sure that you show your work in either exactly the same way or in a way that's very much similar to this, so that the person who's reading your paper can determine exactly how you found or solved each one of your questions. All right, the next problem I'm going to approach exactly the same way. The very first thing I'm going to look for is the location of that vertex, because the location of the vertex tells me exactly which of the rules I'm going to follow from my table above. His vertex is on the circle, so I know his degree measure is going to have to be half that of the intercepted arc. The problem in this picture is that I don't know any of the arcs. However, I do know that their sum has to be equal to 360 degrees. So I'm going to set up a little equation that should hopefully allow me to solve for y. And you should be solving these as we go along also to get some, number one, some practice and to check my work and make sure that the computations that I'm doing are correct. So 2 times 72 would give you 144 degrees for this arc over here. I'm going to make him blue. And then the major arc in this picture, the green one, is going to be 3 times 72, or 216 degrees. And looking at the angle, his intercepted arc is going to go all the way around from this side to his vertex. So his degree measure is going to be half of that of the 216 degree arc, or in other words, 108 degrees. Number 4 is kind of a neat one. This is an angle that's formed by 2 tangents. Just like all the others, I'm going to start by looking for the location of the vertex. It's outside the circle, so I know that the degree measure of the angle is going to be equal to half of the difference between the 2 intercepted arcs. And what's really cool in this picture is that the 2 intercepted arcs, so there's one where the tangents hit the circle, and then the second arc where the tangents hit the circle is this blue one right here. So together, those 2 intercepted arcs make up an entire circle. Since the red arc measures 260 degrees, the blue arc needs to complete the 360 degrees, or in other words, is 100 degrees. So the measure of the angle is going to be equal to half of the difference between the 260 and the 100. Or 50 degrees. I'm hoping that you're checking my computations because I'm thinking that I might have just made a mistake there. 260 minus 100 is 80. Half of 80 isn't 50. it was wrong, I do need to take a minute and go back and fix it. All right, I'm going to jump ahead to number 6 so that this video doesn't run for too long. This guy's a little bit different. I do want you to see an example of how we solve a problem where the vertex of the angle is inside the circle but not at its center. So this is a perfect example. Vertex is in the circle but not at the center. We know that the center is marked by that little black dot. So the measure of the angle is going to be equal to half the sum of its intercepted arcs. Well, the angle in this particular case is 53 degrees. There's its arc, the 3x plus 3. Its vertical angle is over here. The intercepted arc of the vertical angle is this 10x minus 14. So 53 degrees is going to be equal to half of the sum of those two arcs. So half of 3x plus 3, the red arc, plus 10x minus 14, the green arc. So in order to solve this, I'm going to begin by combining everything that's inside the parentheses. In order to get rid of this 1/2, I'm going to multiply both sides by 2. I'll add 11 to both sides. And lastly, to undo multiplying by 13, I'll divide both sides by 13. So I come up with a value of x equals 9. All right, I think I'm going to pull a fast one on you and go backwards now to number 5. This one too, I'm going to begin by looking at the vertex, which is outside the circle. So I know that the degree measure of the angle is going to be half that of the difference between his two arcs. So if I go to the picture and look for his two arcs, there's one in blue, there's the other one in blue. So 3x, the measure of the angle, is going to have to be equal to half of the difference. 4x plus 50, subtract the smaller arc, 30. Again, I'm going to start by working with what's inside the parentheses. From here, I can approach solving this equation a couple different ways. To get rid of this 1/2, I'm going to multiply both sides by 2. I could also distribute the 1/2. There's a lot of different options that I'd have there. And if you solve the equation correctly, no matter which way you solve it, you'll end up with x equals 10. I had really wanted to get down to example 9 because that's really the most intriguing and interesting problem that's on here. But in the interest of time and not trying to go through it too quickly, I think we will save that one for the next time that you come to class. But in the meantime, I guess if I had to pick something that was really, really, really important that you need to take away with you from this lesson today, you really have to make sure that you know and understand how to use all of the rules that are in this table back at the top of page 8. Those are really, really, really key things. You've got to have those formulas memorized, because if you don't have them memorized, it's going to be very hard for you to work with them in class. So put them on flashcards, do what you need to do, but make sure that you have those rules memorized. It's critical to your success in moving forward through this unit.